The basic moral of the story here is that if we are going to count carbon, which everybody's doing, if you go on the web and you enter some sort of carbon footprint calculator, you also have to count, you've got to count the other greenhouse gases too. You can't just count carbon. And it turns out that nitrous oxide is a player here when we intensively manage landscapes. The more you fertilize and the more you irrigate, the more you have emissions of this greenhouse gas. That's the basic moral of the story. So, let's see here. I love talking about water. It's my favorite subject. The rest of the talk is all about water. So, water's funny because normally we talk about the water use of ecosystems as a service that ecosystems provide to society because ecosystems regulate the hydrologic cycle on Earth. And without ecosystems, it would be a lot drier. We would have arid areas. And we know from very old studies that were done in the early days of ecology, when you deforest a landscape, there are many negative impacts on the hydrologic cycle. So ecosystems provide a lot of services. They cool climate because of the evaporation of water. They regulate the water cycle. They control erosion. One thing that happens when you cut down a forest, a lot of erosion into streams. They mitigate stormwater runoff, big issue here in Orange County. And they provide all kinds of other benefits. So if you use water to support an ecosystem, to grow plants, you get all these other benefits. But here in Southern California, water is scarce. We are trying to conserve water. So from that perspective, water use is a cost. Irrigation is a cost. Irrigation uses water resources, and I have to say this because we're here at UC Irvine. Even if you use recycled water, and UC Irvine uses recycled water to irrigate its landscapes, there are still environmental costs. If you walk around UC Irvine, look at the sprinkler heads on campus. They're pink. That means the water is not potable. Don't drink our irrigation water. Basically, what happens is when your water goes to the sewage treatment plant, it goes through an extra treatment step here in Irvine, and we get that treated water. It's treated sewage water, clean sewage water to use for our landscaping, and that's good. We're recycling water. It's recycled, but you can't remove everything from that water. It is not as clean as tap water. It still has some nutrients in it and some other chemicals in it. So when we over-irrigate, that water ends up going into our waterways. It goes into San Diego Creek, it goes into the Newport Bay, and it goes into the coastal ocean. So it contributes to what's called eutrophication, those big bacterial and algal blooms that you see in polluted waterways. So when we use too much water, whether it's clean, potable water or whether it's recycled water, there are costs. So what we want to do is optimize here. We want to optimize the costs, optimize the benefits and minimize the costs. So the question here is, how can we conserve water? We do a lot of work on this in my lab. And there's a really fabulous facility here in Irvine for looking at water conservation. And if you ever have the opportunity, you can go and look at this experiment. There's a place called the UC South Coast Extension Center. Not here. It is on the other side of Irvine, the inland side of Irvine. And it's actually operated by UC Davis. So the University of California has 3 agricultural extension campuses, and we are not one of them. There's UC Davis, Berkeley, and Riverside, and they operate the ag extension. Every state in the US has an agricultural extension. So these guys, normally in the past, the agricultural extension dealt with crops and animals and things like that, but they're starting to look more at urban landscapes. So Darren Haver, the director of the center, created this experiment. 3 landscapes, all using a different method of landscaping. And see, there are these 3 buildings here. These are not houses. They're just empty garages. So they're just there for experimental purposes. Nobody lives in there. But each one of these landscapes is different. This one's called a typical landscape, and it's a fescue lawn, fescue being the most common lawn that we have here. And it's watered with a regular irrigation timer, the kind that you probably have at your house. I have at my house, where you have to program the timer to go off at certain times of the day and the week. Problem with these timers is they keep going off even if it rains, like today. So the second landscape is called the retrofitted landscape. And it simulates a landscape where somebody has come in to a landscape like this and retrofitted some environmental improvements to it. So there are these permeable pavers here in the driveway, which will allow water to penetrate. And it's a different kind of lawn called paspalum, which is supposed to use less water. And the soil moisture system, or rather the irrigation system, is triggered by soil moisture sensors. So if it rains, the system won't go off because the soil's already wet. More sophisticated system. And then finally, this last one is called a low impact landscape, and it's supposed to be the gold standard of urban landscapes in that everything is permeable pavers. All of the plants are native to California, and it's a very sophisticated irrigation system that's triggered by a weather station. So California has a network of weather stations that calculate for you how much water your lawn needs. And if you are hooked into this system, it will control your irrigation system for you. So this experiment was designed to look at pesticides and runoff, but my students have come in and started measuring all kinds of other things because we think this is a really neat opportunity. It's a neat experimental system, and we've been measuring the water budgets of these lawns and these landscapes. And so this is work by Justine Law, was actually a visiting undergraduate from Allegheny College, and this is Nita Bajor, who's a graduate student about to graduate in my lab.